All right. Good evening, everyone. Thank you so much for attending our annual joint NABS and Science and Engineering Division call on how students can do STEM accessibly. My name is Lauren Altman. I am the current president of the National Association of Blind Students, and we are so excited to be partnering again this year with the Science and Engineering Division. Thank you so much to Lewis and John for all of your hard work putting today together. There is definitely a lot of very fascinating panelists that I know we're about to hear from. Thank you to Noah and Nikhil and everybody on the NAB side that also worked hard for putting tonight's events together, both with the promotion and the actual running of the Zoom. We're very fortunate in the National Federation of the Blind that we have so many divisions, because as we all know, most individuals aren't just unifaceted. We are all complex individuals with different identities. And for example, people can identify as somebody who's both a student and somebody that's pursuing a STEM career. You could be a parent of a blind child, and you could be somebody that's interested in rehabilitation teaching. And so we have the great fortune of getting to collaborate with other divisions in order to put on great seminars that are not only meaningful to students, but to other folks that are, interested in the STEM world. I am very excited to hear from tonight's panelists. Thank you so much, everyone, in advance for your time. And, please um, feel free to make sure that you stay muted until the Q&A portion is going to start. And I'm going to pass it off to Lewis to get the next portion started.
So I'll jump in here. It's John Miller, and I'm the president of the Science and Engineering Division. Thank you so much to everyone in NABS for joining us to hear tonight's panelists. So I myself am totally blind and became blind at age 3. I'm a Braille reader. I use a refreshable Braille display. I work with JAWS for Windows, and I work in engineering. I do math and software. I have a PhD in electrical engineering. And I would say one thing you want to do if you're coming up with a math course or a college course or beginning to take courses towards a degree that is in science or engineering is to start your networking now and try to find others that are pursuing the same course as yourself, or perhaps someone who's working in the field. So if you are working in a field such as science or engineering, maybe you just want to drop me personally an email to johnmillerphd@hotmail.com. Mention, which kind of coursework that you're doing and maybe which university you're at, and I can reach back and we can talk specifics and maybe connect you with someone who's closely aligned with what you might also be studying. So other than that, there are some amazing new developments in technology. If you do use JAWS for Windows, the fscompanion.ai has been very helpful website for learning efficient non-visual keystrokes to work with the JAWS for Windows program, to work with Microsoft 365 Office applications. So now I'm going to start to talk with you about our first panelist. And so Kevin Curran, you're going to be hearing from him, and his email is kwcurran, that's CURRIN, at email.unc.edu. And the title of his presentation is Data Analysis Using R Markdown, including tables and chart sonification. If I could just take a moment to talk about Kevin and a little bit more about him. So Dr. Kevin Curran is a research assistant professor in the Department of Genetics at the University of North Carolina at Chapel Hill, and he has a PhD in bioinformatics that he received in 2020 from the University of North Carolina. So if you might be attending one of these institutions, then you might also want to reach him to get some other tips about the campus. So now let's listen to Kevin and what he has to say.
Awesome. Thank you so much for that introduction, and thank you for inviting me to talk today. Today, I wanted to talk about a way to do data analysis using a report format. The specific tool I'm going to talk about is called R Markdown. This is a way to make reports that have a bunch of your data all in one place. If you're doing a bunch of data analysis and you have a lot of tables or you have a lot of charts, or maybe you have some results from, say, running some programs and you have some numerical results and you want to summarize some findings, maybe in a lab course. This is a way to put that all in one document. You can do different types of documents such as Microsoft Word or PowerPoint with Markdown, but I'm going to talk about HTML reports because HTML gives you this really cool ability to have interactive elements. So tables that you can sort or filter, charts that you can use sonification with using new JavaScript libraries that are out now. So I want to preface this by saying I don't expect people to know R, and the goal of this is not to teach you R in 20 minutes or to teach you R Markdown in 20 minutes, but I want to just show you an overview of what's possible to motivate you to learn this if you think it would be useful for yourself. I use this a lot in my own research when I'm doing a lot of data analysis and I have to look through a lot of tables and I have to look through a lot of charts. It's a lot easier than making a bunch of separate Excel sheets or making a bunch of different chart files that I then have to go open up separately and analyze. And this is great if you're sharing data with someone as well. It just makes it a lot more convenient and it really speeds up the data analysis process. Okay, so that was a lot, but I'm going to share my screen and I'm going to share my sound. I've slowed down NVDA to make it hopefully more understandable to more people, but if someone needs it to be slower, just please let me know. Okay, so I'm starting sharing now. So what I prepared is an R Markdown code file and also the resulting HTML document that comes through it. So I'll step through this a little bit, step by step to show you a little bit what this looks like in code, but please don't worry if the code seems overwhelming yet, and what the HTML output looks like. So let's get these set up. Back. So the first thing with our Markdown is you want to tell it the title of the document and what. Could someone remind me of the keyboard command to mute the NVDA speaking the Zoom announcements? Is there a keyboard command for that? Wait a Okay, so the first step here is telling what the title of the document is, and then it will tell you what type of document we want. In this case, it's going to be HTML, and the author of your document. So this is similar to if you're making an HTML web page. So it looks something like this. Introduction to Markdown. Author Kevin Cohen. Output HTML document. Okay, and that's all. That all comes across into your document as a heading level 1, which is over here. Introduction. Heading level 1. Introduction to Markdown. So it just has the title up there, and this is an HTML page. Then I'll skim through the next section, which is just some setup R code. So R Markdown is a way to make a document, but it also allows you to embed some code in there. I'm using it with R code. You can also embed Python code, JavaScript code, HTML elements. Anything really can be handled by R Markdown, even though it's called R Markdown. You can use other languages with it. But I will skim through this beginning here. We just load in some libraries. I won't focus on that too much. And then we load in a data set that I will be talking about today. Okay, now we get to the actual Markdown section. So this is similar if you're familiar with GitHub Markdown or other things like that. It's a little similar. So if you want to make a heading, we put a number sign for heading level 1, 2 number signs for heading level 2, three number signs for heading level 3. So here, since the heading level 1 is the title, I made heading level 2.
Left click test equals to blank. Number, this is an example heading. Blank. Number, this is an example heading.
Okay, and then if you go over to your document,
Introduction to heading level 4 Kevin Cohen. Heading level 2, this is an example heading.
it comes across as a HTML heading. So that's cool. You can put some text in there. I'll just write some text in the document.
We can write some text. Blank. We can also make lists for drop. We can also make lists. Introduction to our markdown in. We have a put in waiting room alert. We can also make lists for example.
So over here, that comes across as paragraph text.
Write some text. We can also make lists for example. Here is a list of fruits.
We can make some lists. I made a nested list here of fruits, and the list is similar again to GitHub or
from to everyone. Kevin Cohen left KW.
Where you have you put a star in front of the bullet point.
Oranges, apples, including Cohen.
If you want to do a nested list, you indent it and you do a plus sign. So that looks like this.
We can also make lists for example, here is list with 3 items, bullet bananas, bullet oranges, bullet apples, including Cohen. List with 2 items, white bullet, red apples, white bullet, 3 apples, out of list, heading level 2.
Okay, so this is all very basic HTML things.
Number. Cohen 11 p.m.
So now I'll show a little bit more of how you can incorporate coding into this. So I'm going to work with this data set called MT cars. It's just got some measurements on a few different models of cars, like their miles per gallon, their weight, their horsepower, etc., how many cylinders they have, and just show some basic analyses with it. So
number analysis of the MT cars data set.
So we have our heading here.
We will use our time presenter. We will use our markdown to analyze the empty cars dataset, which consists of measurements on various types of cars. We can use our code to dynamically calculate information about this dataset. Here are some characteristics of the dataset colon.
Okay, so
time has left the waiting room for this.
You can hear there it says you can use our code to dynamically calculate some info about this dataset. So what I did was write some R code that would say how many cars are in this dataset. I would count the number of rows in the dataset. Then I would say how many measurements on each car. I would count the columns in the dataset. And what that comes across as in the HTML document is it just inserts the numbers there for you. So if I go over, so it sounds like this. You have some R code in there.
Measurements for each car. The average weight left in thousands of pounds right in this dataset is drama left empty cars $W.
So you heard that there was some code commands in there. But if you come over to your report,
out of list heading level 2 analysis of the empty cars dataset. We will use our types of cars. We can use our code to dynamically calculate some characteristics of the dataset colon. List with 3 items. Bullet the dataset contains 32 cars. Bullet there are 11 measurements for each car. Bullet the average weight left in thousands of pounds right of cars in this dataset is 3.21725. Out of list heading level 3.
So that's pretty useful, right? So you don't have to go and manually insert those numbers in once you've calculated them. The R Markdown will evaluate that R code for you and put it in there. So that's one useful thing you can do. The next thing is maybe we want to make a table to look at some of this. So let's look at just the whole data set.
Number table of the empty cars data set. We will display the entire data set in a table below. We can sort the numerical columns in ascending or descending order.
So I'll come over here to
we will display
the table.
Descending order. Show combo box collapsed 10 entries.
So this is a JavaScript-based table. So you hear it says it's showing 10 entries.
Search column edit. Show combo box collapsed 10 entries. Search column edit. Table with 11 rows and 12 columns showing 1 to 10 of 32 entries.
It says showing 1 to 10 of 32 entries, but I want to show the whole table.
Show combo box
so go over here and click on this combo box.
List 10 1 on 4. 25 not selected 2. 50 not selected 3 on 4.
I click on 50. That will contain all of the rows.
Search column table with 33 rows and 12 columns showing 1 to 32 of 32 entries.
So now we're getting 1 to 32 of 32 entries. What's in the first column?
Not in a table cell. Not in a table cell. Out of caption row 1 column 1. Row 2 Cadillac Fleetwood. Row 3 Lincoln Continental. Row 4 Camaro Z28.
So this sounds like the names of the cars.
Row 2 Cadillac row 1.
So we then go over and see what measurements are there about the cars.
Column 2 clickable sorted ascending MPG.
MPG, that's miles per gallon. And if you hear it says sorted ascending.
Column 2 clickable sorted ascending MPG.
If I click on this, it actually will sort the data set for me.
The empty cars data set table showing 1 to 32 of 32 entries. MPG column activate the sort column descending column header sorted ascending row 1 column 2.
So it says activate the sort column descending. It's already sorted ascending. So if I hit enter again, it will sort it descending.
MPG column activate the sort column ascending sorted descending.
So then I will go down and see if it actually is sorted descending.
Row 2 column 2 33.9. Row 3 32.4. Row 4 30.4. Row 5 30.4.
Okay, so it is. So that's cool. So we can sort the data like that dynamically.
Row 2 33. Row 1 clickable sorted. Column 3 clickable seal.
We have sil, which is cylinder. So we'll talk about, in this data set, I'm going to look at miles per gallon, cylinders, which is sil, and weight, just so that these are more commonly understood measurements.
Column 5 clickable HP.
Okay. There's also options, I won't put it here, where you can actually download these as CSV or Excel files. You can configure this JavaScript library to do that.
Column row 6, column 2, 19.7.
Okay.
Number of cars passed into heading level 3.
So now let's think, that was the whole data set. What if you want to answer a question with the data set, with the table?
Let us count how many cars are in each cylinder group. We will use a table to display the results column.
So we wanted to see how many cars there are in each cylinder group. So there's generally for cars that are available to most people, you can have a 4-cylinder, a 6-cylinder, or an 8-cylinder car. And we want to see how many there are in each group.
Not in a table, show combo box collapsed 10 entries. Search column edit. Table with 4 rows and 2 columns showing 1 to 3 on 3 entries. Not in a table cell.
Okay, so there's only 3 entries
Not
here.
in a table cell. Out of caption row 1, row 2, 4. Row 1 clickable cylinder.
So this first column is cylinder.
Column 2 clickable number underline cars.
And then the number of cars that have that cylinder.
Column 1
so
clickable cylinder. Row 2, 4. Column 2, 11.
4-cylinder has 11 cars.
Column row 3, 6. Column 2, 7.
6 has 7.
Column row 4, 8. Column 2, 14.
8 has 14.
Row 3, row 2, row 1 clickable number underline cars.
Now, if this was a much bigger table and you didn't want to go through each row, you would say, well, which cylinder has the most cars in it? We would again click it.
Number underline cars column. Activate to sort column descending. Sorted ascending.
We'd hit enter and it says activate to sort column descending. It is currently sorted ascending. And then so the first row will be the cylinder with the most cars,
Row 12 put in weight column 1, 6.
which is the
Column 2,
6-cylinder.
7. Row 3, 11. Row 4, 14. Row 3, row 2, 7. Row 3, 11. Row 2, row 1 click.
Work right there.
Number underline cars column. Activate to sort column ascending. Sorted descending.
There we go. I sorted it ascending by accident.
Row 4, 14.
Okay. So the 14
Column 1,
cars
6.
is in the
Bella Teta responds to meeting
6-cylinder
alert.
there.
Column 2, 7. Row 3, 11. Row 4, 14.
14
Column 1, 6.
is in the
End of table 6. Column out of link previously.
So that's
Heading letter explorer. Heading
some examples of using tables. Now, the really
X column
most
17.
cool part, in my opinion, is using this to analyze charts. So there's a new JavaScript library that's a couple of years old that's developed by some of my friends here in North Carolina, Sean Muehlin and Juliana Langston, called Chart2Music. And it's a JavaScript library that allows you to make sonified charts, and you can link them to visual charts. So as I mentioned before, R Markdown allows you to embed JavaScript directly into your document. So I did that here and combined it with some R code. It gets pretty complicated, and I'm working actually as a research project to make this more streamlined in R. But currently we have to make some R code, then we have to send some data sets over from R to JavaScript and then program on that. So the code can get kind of complicated right now, but there's ways to wrap that in functions that we're going to work on. So for now, I'll just show the result.
Let us explore the relationship between the weight. Heading level 3 weight vs not miles per gallon.
So let's now look at weight versus miles per gallon using a sonified chart.
Let us explore the relationship between the weight and miles per gallon of a car. We will display the results using a scatter plot comma including sonification for non-visual access column. Sonified chart titled work weight vs not miles per gallon work dot scatter chart dot x is work weight left per n thousand pounds right per n work from 1.513 to 5.424 continuously dot y is work miles per gallon work from 10.4 to 33.9 dot use arrow. Keys to navigate dot press H for more hotkeys dot application weight. So
as you heard, there's a legend at the top of the chart that tells you the title of the chart, what the X and Y values are, and what the range is. Now there's a forms mode box here I can click to go into the chart.
Weight vs not miles per gallon. Sonified chart titled work weight vs.
Okay, so I'm in the chart now, and I can move around with the arrow keys to hear an audio representation of the magnitude of the points, and also it will read the numbers associated with the X and the Y values.
2.2, 32.4. 2.32, 22.8.
So I'm just hitting the right arrow key to go around the chart now.
2.465, 21.5. 2.62, 21.
I can hit home to go back to the beginning of the chart.
1.51.
I can hit end to go to the end of the chart.
5.424. 1.
So, and I can also hit shift plus end to read the whole chart at once. And it sounds like this. And I can go backwards. And the panning that hopefully you hear will go through the x-axis. So things on the left side of your ears are on the left side, and as it goes toward the right, you're moving along the x-axis. And the y value is what is being changing in pitch. And what's really cool, I think, too, about this chart is if there's space between points, if there's a different amount of space between points, when you play it all at once, it'll put pauses in there to let you know that some points are further away. So if you listen again, you can hear that the point on the far rightmost part of the x-axis is a little bit further away from the other points. It's a bit of an outlier. So that's a really cool thing to be able to detect really quickly with these sonified charts. That might take a little bit longer if you're using another non-visual, non-chart based approach. You can speed up the chart.
Cube feed, 100. Cube feed, 50. Cube feed.
You can slow it down.
Feed, 1000.
And if you need help, there's a help command. If I hit H.
Link table with column 2. Column 1 out of 10 heading level 1 keyboard. You can use the below keyboard shortcuts to computers. Column A emulate home key, use same action. Table with 20 column 2 description. Column 3 common alternate keyboard shortcut. X column 21 PM. Row 2 column 1 move to next point. Column 2 right arrow. Column 3. Row 3 column 1 move to previous point. Column 2 left arrow.
Those are a few examples. I won't go through all of them. Okay, so that's really cool. This is an example of a scatter plot.
Heading level 1 in heading level.
There are other types of plots you can use.
Does the mouse per element depend on how many cylinders it has? Question. Let's tick use an plot to answer this question, including sonification. We will first look at average mouse per element.
So one question I might want to use a bar plot for is, does the average miles per gallon of a car change based on how many cylinders it has? So
sonified chart type cylinder type cylinder dot y is quote sonified chart titled quote average mouse per gallon by cylinder quote dot bar chart dot x is quote cylinder quote from 4 cylinder type cylinder dot y is quote average mouse per gallon quote from 15.1 to 26.6636 dot use arrow keys to navigate dot press H for more hot application average.
And for those who are low vision, you may see that you can put the plot here too, so you can look at the plot as you are listening to it. So there's 3 bars in this chart.
4 cylinder, 26.6636.
So here it says for 4-cylinder, the average miles per gallon is 26.
6 cylinder, 19.7429. 8 cylinder, 15.1. 4 cylinder, 26.6.
So we can hear that as you go from 4 cylinders all the way up to 8 cylinders, the miles per gallon decreases.
6. 4 cylinder.
Okay. And we can even do. Say we want to get more granular with the data set, and okay, we looked at the average per cylinder, but what if we want to look at the distribution of the data using something like a box plot? Well, there's options for that as well using this chart to music library.
However, let's examine the distribution of the data to get a more complete picture beyond just the averages. We will use box plots to do this, including small, 4 cylinder, 33.9-21.4. Application mouse per gallon, cylinder, mouse per gallon.
So what we have here are 3 box plots, 1 per cylinder, and the box plots show the distribution of the data across miles per gallon. So the way that Chart to Music does box plots is pretty cool. You can listen to it all at once. It sounds, if you want to listen to one box plot, say for 6-cylinder or 4-cylinder, it sounds like this. We slow it down a little bit. So it's playing the maximum, the quartile, top quartile, the median, the lower quartile, and the minimum all like really fast next to each other. If we want to go over to the 6-cylinder bar plot, we hit the right arrow key.
6 cylinder, 21.
It plays all of those notes, and then we can go over to the 8-cylinder one.
8 cylinder, 9.
So you can hear that the whole distribution is shifted down. It's not just the mean that's shifted down.
6 cylinder,
so this is what it sounds like for 4-cylinder. I'm sorry.
4 cylinder, 30.
Then we go to 6.
6 cylinder, 20. 8 cylinder.
If you just want to listen to a specific statistic, you can use the up and down arrow keys to cycle through them.
High, 4 cylinder, 30.
High is max, so you can just listen to the maximum. Those are the max values across the 3 groups.
Q3, 8 cylinder, 6. 4 Q3, 4 cylinder.
The third quartile is Q3.
4 cylinder, 30.4. Median, 4 cylinder.
You can listen to the medians, etc. You can also go down to the first quartile and the max.
X current 24 PM.
So there are other charts that you can do as well. There's heat map support. There's candlesticks. There's various different types of charts. You can do multiple groups within a chart, such as if you have a line chart that has 2 or 3 lines, you can listen to the lines separately, or you can listen to all the data together. So if this is something that you would be helpful for your research, really looking into this chart to music library would be great. It's a JavaScript library, so you can use it with JavaScript. I have just sort of hacked it into an R report here because you can put JavaScript within an R Markdown document. Right. So thank you for your attention, and I'll be happy to take any questions.
Hi, this is Indira Duba. I'm mother of Sai Vate. He goes to Texas School for the Blind. He's in 6th grade. So yeah, he's in middle school. I'm just wondering how a blind student can read these plots, like scatter plots, box plots. Is there any tool to create them?
Yeah, so the simplest way would be starting using Microsoft Excel to make scatter plots. And there's more complicated ways once you learn to program, like the R statistical programming language allows you to make scatter plots, and it's all text-based. So you're writing code that says scatter plot, and then you put in parentheses like what the X and the Y values are. So it's all text, and then once it's created, that's going to be the visual part. But that part is going to be inaccessible. So this is where we're trying to add in these sound-based sonifications to the chart so that you can listen to actually what you're creating.
Okay. Okay. So R is like a pretty old, right? Like, are there any new AI tools or does Python support it? Like, I'm a software engineer and I started teaching my son HTML and JavaScript to start with. And eventually we'll go to Python. So I was just looking for some AI tools which will ease. Yeah, there are Cursor AI which you can be inbuilt in VS Code, but are there any more which will ease his job?
In terms of creation, I'm not familiar with how to create charts with AI, but if you want to read an existing chart, you can give ChatGPT a PDF, a PNG or a JPEG of the chart, and it does a very good job describing what the chart shows.
Okay.
Yeah.
Thank you. Yeah, thank you.
And that PNG would be GPT-4.
Perfect, perfect. Does anyone else have any other questions? If you do, please raise your hand. Preliminarily, I believe Noah, you had your hand raised?
Yes, just a question. I noticed when the sonograph was playing, the some of the pitches seemed to play at the same time or close to the same time, and others were rather spaced out between the time they were played. Is there a relationship between the that timing, which can be of some use to a listener in sort of um, quickly interpreting the scatter plot or the data? Or is that sort of the speed at which they're played relative to each other sort of a consequence of processing and et cetera, and not really useful?
Oh yeah, it actually is it's proportional to the space in the x-axis. So if there's a gap in time between two notes that say 2 seconds and the next two notes it's only a second, then those notes should be notes 1 and 2 should be twice as far apart as notes 2 and 3. That's called continuous mode, and you can actually turn it off so that everything is played uniformly across, regardless of what it looks like on the plot. But continuous mode, which is what I was showing, is really helpful because it kind of lets you feel that outlier or like how spread out the data is or how bunched up it is.
And so, Kevin, just before we move on to our next speaker, how could a student on this call try out this technology to perhaps make a report and have the table speak, or to try out the sonification method that you are using? How could they do that with one of their data sets?
So for making the charts, there's great tutorials on the Chart2Music website, and I can share the website in the email afterwards. That does require knowing JavaScript, but they do have some code examples. And for learning R Markdown, there's great tutorials on R Markdown has its own website. That's pretty easy. If you already know Python or you know R, you can embed either of those into your R Markdowns with the tutorials. And I'm also happy to help anyone who has any questions and wants to get started. Because I think this is a really, like my talk is just to motivate people to think about this as an option to learn, and I'm happy to help them learn it.
Perfect.
John, do we have time for one other question?
I'm hoping we can email that next question in.
Yes.
And there might be
We can do that.
a couple minutes if you stay around into the next hour just before we close, if you remind us. but we're going to move on to the next speaker. So I wanted to give the introduction to Dr. Ned Lindholm, and he has received his bachelor's degree in chemistry from North Dakota State, and he has a PhD in physical chemistry from the University of Utah. So since losing his vision, he is an adjunct instructor at the Salt Lake Community College. So he is teaching in Salt Lake, right there in the state of Utah. And he is a leader in the Salt Lake chapter and on the state board of the NFB of Utah. I found him to be quite approachable, and he has brought 2 scholarship winners over to the Science Division meeting at National Convention. So you will often find Ned Lindholm at an NFB convention. So Ned is going to be talking about secondary effects of lab chemistry experiments combined with adaptive technology. And so these secondary methods, these secondary effects of chemistry can be quite effective in producing results and analyzing chemical experiments. So I give you Dr. Ned Lindholm. Dr. Lindholm, you might be muted.
Hello, can everybody hear me?
I hear you fine now.
Okay, sorry about that. Thank you, everyone. As John said, my name is Dr. Ned Lindholm. I am a instructor at adjunct professor at Salt Lake Community College. I have been doing chemistry for, probably longer than I care to admit, but close to 35 plus years, having only been blind for the last 13. Now, as John read in my bio, I am a physical chemist by trade, but that doesn't really quite complete the whole story. I am what is called an experimental physical chemist. At least that's what my training was in my doctorate work and in my postdoctorate work. There's a big difference in physical chemistry between what we call theoretical chemistry or computational chemistry and physical experimental chemistry. I've often joked that a experimental physical chemist is one part scientist, another part engineer, another part repairman, as it many times requires you to troubleshoot or engineer a new type of experimental apparatus or machine to get your experiment to work. This oftentimes requires you to think a little bit creatively and a little bit kind of outside the norm. For example, in my doctorate work, working with optics, high-tech optics, and in particular, dye lasers, what we call tunable dye lasers. In other words, we can actually tune the frequency of light to a very specific wavelength. Well, we had to get 2 different ones to fire within 40 nanoseconds. So if we take a second and we break it up into a billion pieces, a 40 nanosecond delay. Well, usually this is accomplished with high-speed electronics. However, when you're working with limited research budgets, sometimes those high-speed electronics just are not all that available. So we end up creating a nanosecond delay by using the speed of light. If you take the speed of light and divide it by length, you can get essentially a 40 nanosecond delay by sending that light through a 40 meter path length. And these are the types of problem-solving skills that are required for an experimental chemist. It often requires you to come at it in a different direction. So this is kind of the approach I've taken to adapting a lot of chemical experiments or working in the actual lab now as a blind individual. Thinking a little bit outside the box, thinking about what I've entitled secondary effects. So if you think about an actual chemical experiment, usually when you go into the laboratory to work a chemical experiment, we usually are featuring one particular aspect. If you are learning about oxidation reduction chemistry, then you are working with chemical reagents designed to illustrate that particular phenomena. The movement of electrons from one compound to another. Usually this is observed or demonstrated with something as simple as a color change. Well, as you might have guessed, that becomes a little problematic for someone who's visually impaired. Yes, we do have adaptive technologies that will tell us when a particular thing has changed color due to colorimeters or other types of devices. But the thing about chemistry is there are often more than one particular phenomena being played out in that particular experiment. The experiment often is accompanied with several other different phenomena, such as an evolution of gas or an endothermic or exothermic process. Now, before I get too bogged down into terms, when I say endothermic and exothermic, that is a fancy way of saying temperature change. So by tracking one of these other secondary processes, we can often get more indications or track data on what is happening inside an actual chemical experiment. For instance, just to kind of illustrate a recent experiment that was done, and again, I kind of apologize for if I get bogged down in chemical symbology or chemical symbols here. A reaction we recently carried out was again an oxidation reduction reaction, but also something known as a hydrolysis experiment. Now, hydrolysis is a fancy word for splitting water. We all know the chemical formula for water. I think even we all learned it from early grade school. H2O. Okay, two hydrogen atoms bonded to a central oxygen atom. Okay, the water molecule is an extremely stable molecule, which is why it's so useful, why it's so abundant. In order to break that, we have to input the system with a fair amount of energy to split the hydrogen from the oxygen and attach the oxygen to another compound. In this case, the ionic compound called potassium chloride. They might be saying, what in the world is potassium chloride? Well, this is your water softener salt. Okay, things we put actually in our water to treat it. But by attaching that oxygen, we can create a chemical known as potassium chlorate, which has many other uses. But this is your typical oxidation reduction chemical experiment. Now, in order to get an indication that this reaction has actually occurred, oftentimes we're waiting for long periods of time, and only at the end of a very long period do we understand if we've actually been successful in this experiment. However, one of the key byproducts of this particular reaction is hydrogen gas. Now, normally in a standard chemical laboratory, when a byproduct is created, it is often just left to vent up a fume hood or disregarded. But this secondary byproduct can actually aid us as blind individuals and letting us know that this reaction has occurred. This may be something as when I first did this reaction, something as simple as attaching a balloon to the end of my reaction apparatus. And thus, when the reaction was occurring, one indication of success was the inflated balloon, something I could easily feel. The tactile inflation of the balloon let me indicate that the reaction was occurring and that we were getting a successful product in this reaction. Well, who says this has to be a simple balloon inflation? Okay. With adaptive technologies such as Independent Science's Talking LabQuest, we can now hook up or take a measurement of the gas being evolved as a function of pressure, measuring how many torr or millimeters of mercury are being eluted at what specific time as well. This can actually indicate us a idea of reaction kinetics, which is a fancy word for how fast a chemical reaction is occurring. So through the use of, again, what would normally be discarded as a secondary product, we can actually glean some useful chemical information and some indications of what is happening in our experiment. And this is kind of the idea or the kind of central point of the work I am doing right now. Are there secondary methods? Are there other phenomena beyond our primary objective in a chemical experiment that will allow us to take measurements or to get gleanful, useful information in a particular laboratory experiment? Now, again, this is an ongoing process, work that is continually being done and continually tried to be improved upon. And again, it is required a mix of both a little bit of problem solving, troubleshooting, and a little bit of adaptive technology. And any student attempting to or wishing to study chemistry from both a hands-on laboratory perspective as well as a classroom perspective has to have this type of nimbleness of thought, has to have this agility of thought, to be able to think, is there an alternate way I can accomplish a central experiment by using something that I can actually measure, I can actually feel tactily, or measure through adaptive technology? And this is kind of the crux of all the work I'm doing right now. The potassium chlorate experiment is kind of the latest example. And other things, though, that have helped too in doing kind of this work, I've also discovered some other tips and tricks and to help me along the way, keep track of many of my records that I take within a chemistry experiment. For instance, one things that I've known, and I apologize, this is going to become kind of a laundry list of lessons learned over the last several years I've been attempting this. But one of the things that I've also noticed too when working in the laboratory, when working with actual chemicals, I don't know if any of you have ever read a chemical label before or have actually had someone try to read it to you as a blind individual, but they contain long numbers long formula names that some people just don't know how to pronounce. And what in the world is it when we hear something that's read to us by the name of bis-2-fluoroethyl sulfide? One thing I've found to help with my work has been to focus on other aspects of of chemical naming. In other words, the CAS number. In order to keep my record straight, I often find it much more useful to keep track of the actual chemical abstract service number rather than the actual name of the chemical. Now, for someone who's not familiar with a chemical abstract service number, this is actually a number that is given to a chemical once it appears in any type of literature. Every chemical out there has a unique number associated with it. And oftentimes communicating a chemical this number becomes easier than trying to pronounce a very long name. For instance, in an upcoming work or upcoming experiment I hope to do soon, the chemical reagent to be used is thionyl chloride. Now, thionyl chloride, for those who are kind of scratching their heads wondering what in the world that is, it may sound unique and exotic, but to a chemist, this is actually a fairly common chemical to use. It's very useful for sticking a chlorine atom on a long carbon chain. And that's actually something that's quite useful for a chemist. Now, trying to communicate thionyl chloride to your verbal records can be a little bit tricky. However, with given the number 7719-07-7, well, that becomes a little easier to discern, a little easier to keep track of in both Braille and spoken words. The other thing that has been tricky learning is getting used to screen readers to read back many of my old notes and chemical texts. Hearing JAWS kind of mispronounce a standard word is sometimes humorous. However, when it's dealing with something as reactive as a chemical product, it can become a little less funny. Getting used to JAWS's tones and how JAWS actually repeats different chemical names has been a little bit tricky. And this is where I fall back on some very basic chemical facts about chemistry in the periodic table. For instance, when I come to an actual chemical formula, sometimes it's easier for me to just arrow through each individual symbol, realizing that JAWS's raised tone for a capital letter indicates a new atom. In chemistry, one very basic fact that often gets glossed over is every symbol on the periodic table of the elements begins with a capital letter. So two capital letters next to each other being tabbed through indicates two different atoms. And every time a number comes in between two letters, realizing that that is a number indicating how many atoms were in the particular formula, were in the atom preceding it. It's little basic facts like this that I learned many years ago, took for granted, and realized that, remembering these basic facts has helped me continue on with chemistry while being blind. The other things that has also helped is, practice. One thing we take for granted too is a mastery of any sort of subject requires practice, requires repetition. The old joke when somebody has asked, how do we get to Carnegie Hall? The punchline is practice. Forgetting that many times when we see somebody who has mastered a skill, we often are seeing a repetition numbering in the hundreds of thousands. Many of my students marvel when I ask me a question and I'm able to rattle it off the top of my head. They are amazed. How do you do that? How do you remember that? And I smile and I just simply say, you are hearing repetition number 10,420, literally. It wasn't so fast and quick when it was repetition number 1 and 2, which is where they're at. Knowing your subject can be a huge part of interpreting chemistry. And for this, I wish I had some sort of magic shortcut. But there really is no substitute for repetition, for practice. And while this may seem tedious at times, given after the third, fourth repetition, the third, fourth time going through it, you will find yourself remembering it and making connections that you never would have thought were there earlier. A very famous scientist once said, "I'm not very smart. I just stick with problems longer than most." Okay? This is a quote that is attributed to Albert Einstein, who admitted his theory of general relativity and special relativity was not from some stroke of genius, but rather the product of years and years and years of practice. And I think for us as blind individuals, this is what is going to require to become good at a subject like chemistry in the laboratory. Now, you might say, how in the world do I get practice with chemicals? And in by no means am I encouraging you to try to purchase chemicals and try this in your home. However, practicing drying up liquid through a pipette can easily be done with simple tap water. Okay, drying a simple disposable pipette to slowly inject liquid into a container is something that can be done with, well, different tap water or another type of household product. Okay, stirring and dissolving a solid into a liquid can easily be practiced with something as simple as, well, say, salt and water. Learning to filter different substances, solid from liquid. This can be done simply by just using something as simple as a coffee filter. While you might be saying this sounds like home management, something I would do in a kitchen, well, when you break it down, the motions are similar. The principles are similar. The only thing that differs is the arena, going in from the laboratory into the kitchen. And these are kind of the connections and parallels I've actually made throughout this second part of my career in learning how to make or how to get better at laboratory technique using both secondary effects and adaptive tech. Now, again, my entire career, there's a little bit of a story there, has been to find some of the most off-the-wall ways of getting things done, making measurements, using alternative techniques. And this is kind of an area where I am focusing on the rest of my career. So I feel a little like I hope that was what you guys were looking for, but I don't know how long I've taken here on this.
It's about the right time. I think we could open it up for questions.
Okay.
Is it okay if I jump in first?
Go ahead.
Go ahead.
I thought that was a very great talk, and it reminds me of so your talk about using what you've learned in research to adapt to accessibility. I think for me, like it went the other way. Since I was blind from birth, it went like everything I struggled through with making things accessible in my high school and undergrad really prepared me to do graduate research. And that's like a connection that I think is good for students to know. If they've already struggled with this and they've had success with adapting things and coming up with solutions that other people don't have to know, those are great skills that will make you be a successful researcher. And
Yeah.
also, I really loved your emphasis on you have to know your subject. And in my area of genetics, once you learn the subject really well and you know how people display data, you can kind of know what a graph is just by reading the legend in the figure if you know how people tend to do things. And there's so much you can get from reading a paper just by knowing the subject so well and how things are represented. So I thought that was great.
Oh, thank you. There really is no substitute for background knowledge or foundational knowledge.
Very true. All right. Are there any other questions from the audience? If you do, please raise your hand at this point and I'll acknowledge you. Seems like there aren't any questions as of now.
Well, I just have a comment or a question that Ned
Oh,
could
go ahead.
respond
Sorry,
to.
sorry.
Is there, do you have some ideas for how to engage blind high school students taking their first chemistry course or a college student walking into that first chemistry course in college. I have heard over the years that chemistry is one of those daunting subjects to blind students, where we might feel that the lab experience, we didn't get as much as we could have done. Perhaps we found sighted peers or sighted partners were doing more of the work. So have you had some thought about how to inspire or put people on the right path for also doing chemical experiments?
Well, a good number of chemistry, there's a good, I should say, a good amount of chemistry is actually around us every day in just simple household products. For instance, we to make a grade school volcano, we often, they often say, okay, mix vinegar and baking soda together, to make that big foamy mess for making lava. Well, that's an actual acid-base reaction, a reaction of sodium bicarbonate with vinegar to make it's what we call in chemistry a double displacement reaction with a gaseous byproduct. There is kind of, in my opinion, there's a lot of chemistry that's being done every day in the household without people even realizing. I mean, baking an actual, just simply something as simple as baking a cookie, well, you're adding baking powder, sodium carbonate. You heat it up, it releases CO2. That's what makes the thing fluffy. So what I'm kind of working on, another project I've been working on, is actually what I call just, almost, for those of you who remember Bill Nye the Science Guy, almost what you call household chemistry experiments that, a blind student could actually do, giving him a little bit of base knowledge for that. And the problem is once you get to the actual college level and taking even just something as simple as a general education class, I mean, that's kind of a daunting first step to try to get into. So one area I'm kind of working on is trying to make what really amounts to, grade school and elementary school introductory chemistry, just little short courses to give that base knowledge. Now, that's going to simply lay a foundation. Unfortunately, at that next level, when you get there, yes, you are correct. It is a very intimidating, and a lot of it is because of, the strange terminology or the strange, almost second language that chemistry is. And I've kind of prided myself on kind of being a demystifier of that, or what I call a translator of it. You'd be amazed at how many very, very simple concepts are given long, very complicated, very intimidating names. So, I don't know if I've actually answered your question here, John, but I think it honestly is a matter of interpretation. And a matter
I think you did. I think you did. It's been a very fantastic and enlightening presentation. And you're reminding me of the two things, the volcano experiment, just for folks to get their hands on chemistry, to go purchase some baking soda, purchase some vinegar, mix a little bit of that stuff together. It foams, it makes sound, it's bubbly, you can touch it, it's harmless.
And if you do it in a bottle and stretch a balloon over the top, you can get the balloon to inflate.
And how impressive is that, doing chemistry right there? And then we know that chemistry is approachable at home outside of the class setting. So why not then move it into the class and into the lab setting? Mm-hmm. Thank you very much for your presentation. And thank you for all the work that you do in the National Federation of the Blind. Our next presenter is Kennedy Stomberg, who's going to be talking about Systemic Access, the mentoring program with the Science Division. Kennedy?
Thank you so much, John. And we've had some really wonderful talks, so thank you also to the speakers. And after hearing these talks, you may be inspired in one direction or the other. On one hand, you may be thinking, wow, these speakers have come up with some really great solutions for making things accessible, and I wish there was somebody I could brainstorm with every week or every 2 weeks to talk about that. Or you might be thinking on the other end, wow, these speakers were so great, and I am somebody who also knows about a lot of accessible solutions, and I would love to help students and newer scientists to think about those solutions. And in either case, you would probably be a good fit for our mentorship program called Systemic Access. You can sign up to be a mentor or a mentee, or both. In terms of what we offer in the program, we do ask that mentors and mentees meet at least once a month. That's the only kind of quote unquote mandatory component of the program, is that you meet together once a month. And there you can kind of talk about, any STEM related questions you might have, come up with solutions, talk about how things are going. It's a great way to connect with another blind scientist. We also have a Slack group now with several channels, including a channel for asking and answering questions, a social channel where you could, put together some virtual hangout time with other blind scientists and engineers. This is for all STEM fields, so we have that. We also have monthly events. Some of the time, those events are speakers, so people that come and either talk about their research or talk about kind of how they've made things accessible in their subject, as the last speaker did. And sometimes those events are a little bit more social in nature. We call them kind of like a Zoom happy hour. So we come together on Zoom, and maybe you've been brainstorming some things with your mentor, but you would love to hear from other people in the group. So it's a way of asking questions and also sharing resources. So that's a little bit about our program. We're open to pretty much anybody in science, technology, engineering, and math fields. If you would like to learn more, you can reach out to us at systemicaccess@gmail.com. And in case you're like, what did you just say? I think it might be in the chat, but if it isn't, it definitely is in the email that Lewis sent out, so you can reach out. The program is run by Amelia and myself. If you reach out and indicate your interest in the program, we will be asked to fill out a form, and then you will meet briefly over the phone or Zoom with either Amelia or myself to kind of make sure we understand your needs and your strengths. And then we would match you up with, depending on what role you chose, either a mentee or a mentor. And once we facilitate that connection, you guys would kind of go from there. So that's a little bit about the program, kind of a brief rundown, and I am happy to take any questions.
Okay, and I just so everyone knows, I just did paste the name and email address for Systemic Access into the chat. If you do have any questions about this, please raise your hand and I'll acknowledge you.
Kennedy, could you tell us when the next monthly meeting will be?
Yes, the next monthly meeting will be Tuesday, February 18th at 6 p.m. Pacific, 9 p.m. Eastern. I don't want to announce the speaker officially yet because I'm still in the process of reaching out to them. But we do have a tentative plan, and we think that it will be a lot of fun. So please feel free to come. We've started this year to advertise our events on the mailing list. So you should see an announcement from us about that as soon as we kind of have all the details firmed up. And one thing I want to mention that I forgot to mention before is we're doing something a little bit new this year where we're giving people the opportunity to speak about either a recent publication or recent research they've been doing, and get an opportunity to speak about that in a safe environment, and also to kind of practice doing it in a way that's accessible, since there are a lot of blind individuals there. So if you're doing research, or if you know of somebody who is, that might be willing to try practicing their hand at presenting it in an accessible way, please also reach out to that Systemic Access email address. We have a separate form for that. So we're definitely in the market for speakers.
So I want to take a moment and thank everyone who made tonight's presentations come together, and then we could see if there is still one or two more questions out there. But I did want to thank Kevin Curran, our first speaker, talking about how to generate and consume statistical data and graphs, and then Dr. Ned Lindholm about making chemistry accessible by paying attention to secondary effects, as well as Kennedy Stomberg, who just talked about the Systemic Access Program. Of course, I wish to thank Lauren Altman, the president of the National Association of the Blind, as well as Nikki and Noah, who are our Zoom hosts this evening, and Kaylee, who is our NABS publicist. So thank you to all of you, and also to Louis Maher, who found these amazing speakers to share with us about doing STEM. So before we do close down, I knew there was one question that I had postponed to the end. If that person is still here and has a question, we could take it. And of course, the speakers can be reached offline, or you can share your comments back to Lauren or myself, and we can try to get your questions answered after the fact.
I did ask a question in the chat to Dr. Curran. I wanted to know if your sonification software solution could work on a Debian-like system or something, so that if you were doing a supercomputer run, you could check your data quickly after you get it before you log off.
That's a great question. So I think you're thinking of something like running this in the cloud or running it on a Slurm type system or something like that. The short answer is you can certainly run these programs. Like you can run an R Markdown script on a remote computer through Debian or any other sort of remote system. But currently, you would have to download the HTML report to your local computer and open it. To my knowledge, a lot of the tools that people use to export visuals on the cloud aren't really that accessible. So if you're trying to open the HTML file on the remote server, at least in the systems that I work on at our UNC supercomputers that use like a RHEL system, they don't, all of the things that my colleagues use to use graphs and things remotely don't work for me. So I have to download everything to my local computer that I want to then use visuals or sound for. But that doesn't mean that there's not something out there that I'm unaware of.
Can it be as simple as doing a secure copy to get the file to the local machine, or is it more complicated than that, Kevin?
That's all I do, yeah, is using an SCP to get it back. So it's just one extra step. Though I know some people really in my lab really love those systems that let you treat the cloud computer like it's your local, with opening up all of the programs. They call it on demand is what we call it in ours, but that just unfortunately doesn't work. But yeah, adding that extra step in for a lot of us is probably not something that we're going to notice, because we do so many extra steps for everything. So yeah, it is simple. It's on the command line.
And that local report is then available for your notes to tie back to your experiment for later reference.
That's correct. Yeah, I did not mention a lot of these stuff. I do run them on a command line. I run R and R Markdown reports. I generate them on the command line and then just open up the HTML file.
That's a common theme across the blind community.
Yes. I would definitely say learn how to use the command line if you want to be a data analyst.
Well, I want to be respectful of everyone's time. So if you come across other thoughts over as you are mulling these presentations over, don't hesitate to reach out to me or to one of the speakers directly. And we look forward to hearing your feedback and your successes, both with analyzing statistics, and doing chemistry. Thank you so much for the call this evening. So we should stop the recording.